Hello everybody, welcome to our next topic, which is exercise 10.5, looking at volume and capacity. So volume is basically the amount of space that occupies an object, and it's usually measured in units cubed. Now what that means is I could have centimeters cubed, meters cubed, millimeters cubed, kilometers cubed. Okay, it's whatever our unit is cubed to the power of 3. Okay, unlike area, which is squared, and just perimeter, we just use the unit on its own. So capacity is basically looking at volume, but looking at it in terms of a liquid. Okay, so capacity is the amount of substance that an object can hold, measured in mils and liters. So basically our conversion that we're going to be looking at is 1 centimeter cubed holds 1 mil of liquid. Okay, so if we had a cube here, but 1 centimeter by 1 centimeter by 1 centimeter, the volume would be 1 times 1 times 1, which is 1 centimeter cubed, which is the equivalent of 1 mil. And we're going to look at what those conversions are. So in terms of converting units, this is what we're going to be looking at. Okay, so the same way that we have converting perimeter, converting area, we also have converting volume units. So here, again, we just follow the arrows. So millimeters cubed to centimeters cubed, we divide it by 10 to the power of 3, which is dividing it by 10, divided by 10, divided by 10. Okay, dividing by 100 cubed is divided by 100, divided by 100, divided by 100. Okay. Divided by 1,000 cubed is divided by 1,000, divided by 1,000, divided by 1,000. You get the idea. And working the opposite way, of course, if we're going kilometers cubed to meters cubed to centimeters cubed to millimeters cubed. This is based on volume. So volume units are usually going to be our millimeter, centimeter, meter, and kilometers. But when we are talking about capacity and talking about liquid being held in a 3D object, we usually refer to things like mils, liters, kiloliters, megaliters, and gigaliters. Okay, in the conversion of units, once you've converted the way that we go here from 1 centimeter cubed to 1 mil, is we can then convert the mils into liters, kiloliters, megaliters, or gigaliters. So converting between units of volume and capacity, okay, these are the things that we need to remember. So 1 mil equals 1 centimeter cubed, 1 litre equals 1,000 mil, which is the equivalent of 1,000 centimetres cubed, and 1 kilolitre is the equivalent of 1 metre cubed. This will make a little bit more sense when we go through some examples. So basically here we are asked to convert metres cubed into centimetres cubed. So when we convert metres cubed into centimetres cubed, we need to times it by 100 cubed. Okay, so whatever our number is, 74, we're going to times it by 100 cubed, and we get our answer, and of course our units will be in centimeters cubed. The next one, we're looking at converting millimeters cubed to centimeters cubed. So millimeters cubed to centimeters cubed, we are going this way, so we are dividing by 10 cubed. So we take our number, which is 4,600, and we divide it by 10 cubed, and of course we get our answer in centimeters cubed. All right, the next one is the difference between our volume and our capacity. So here we're being asked to convert from centimeters cubed to mil. Okay, so we know that 1 mil is the equivalent of 1 centimeter cubed. Therefore, 683 centimeters cubed is going to be the equivalent of 683 mil. All right, so final one, 4,600 centimeters cubed to now liters. Okay, so what we need to do first is make sure that we can convert our milliliters to liters and liters to milliliters. Okay, so we know that 1 mil again equals 1 centimeter cubed, so we've got our 4,600 centimeters cubed as per the question, which is the equivalent of 4,600 mil, and then we've got to convert our mil to liters because that's what the question is asking. And in order to go from mils to liters, we got to divide it by 1,000, which is what we've done. So 4,600 divided by 1,000 is 4.6 milliliters. Okay, so all of this involves using our conversion of units chart. Now into looking at volume of prisms and cylinders. Okay, so we're looking at our three-dimensional shapes. All right, the volume is always going to be looking at calculating the area of the base, okay, in terms of a cross section, multiplied by the height of that object. Okay, so this is what we're talking about. We calculate the area of the base and then multiply it by the height. Okay, so this formula is what we are basically converting for all of our shapes. So the main things that we're going to be looking at, a cube, we do the base area, okay, would be length times length if we got a cross section over here. And then we're timesing it by the height, okay, of our shape, which is also L. So we get L cubed. For a rectangular prism, okay, if we look at our base, we've got H times W, okay, and then we're timesing it by the height of the entire object or the length of the entire object. So we get W times H times L, okay, length times base times height. Triangular prism, okay, our base or our cross section of the shape, if we were to cut this up into slices that were all equal, we would get all of those triangles. Okay, so basically our cross section here is a triangle. So we know that the area of a triangle is half base times height. Okay, and then we're going to multiply it by the length of our shape. So we get half times base times height, the triangle part, times the length of the prism. And similarly with a cylinder, okay, our cross section is a circle. The area of a circle we know is pi r squared. And we're going to multiply that by the height. So pi r squared times h over here. So using these formulas, we're basically just going to be substituting the numbers in. All right, moving on to some different shapes, okay? These work a little bit differently in terms of the formula is now going to be given to us. So a rectangular based pyramid, okay? We have our rectangular base, which is length times width, and then we're going to be multiplying it by the height. So for a volume of a pyramid, we do 1/3 times the area of the base, so 1/3 WL, and then we multiply it by the height. So in other words, when you put it into your calculator, you're going to go 1/3 times the width times the length times the height. Okay, if the width is this, and the length is this over here. For a cone, okay, we have 1/3 times the base. The base is a circle, which is pi r squared, and then we multiply it by the height. Okay, and then sphere is 4/3 times pi r cubed. Okay, for that three-dimensional shape there. Looking at some examples, okay, we have got this solid shape here where our cross section would be a trapezium. So what you're going to do is find the area of that trapezium. Okay, so area equals half bracket A plus B times H. And then to find the volume, we're going to times that answer by this length of 15. So if we figure out the area first, we've got half bracket 8 plus 13, because there are two parallel sides, times by the height of the trapezium itself, which is 6. Okay, and we're going to end up with an answer of 63 centimeters squared. And then to find the volume of our entire shape, we're going to take that 63 and we're going to multiply it by the length of our entire shape, which is 15, which is 945 centimeters cubed because it's volume. So volume is all about finding the area of our cross section and then timesing it by the height of the object. All right, so if we look at these ones here, okay, we've got a square-based pyramid, okay, and for that we do 1/3 times WLH, where our width is 14, our length is also 14, okay, because it's a square-based shape, And then our height is going to be the height of our rectangular base pyramid, which is 23. So if we substitute those numbers into our formula, we then end up with approximately 1,503 meters cubed. Remembering our units all have to be in the same units for us to do the calculations. This one here, a sphere, okay, our balloon shaped sphere. So we take our formula, which is V equals 4 over 3 times pi r cubed. If this entire length is 30, that means that's our diameter. So our radius is going to be half of that, which is 15. So we're going to do 4/3 times pi times 15 cubed in the place of r. Put that in our calculator and we will get our answer in centimeters cubed. All right, another example here, the final one, is a bit of a worded question. So we're looking at an ice cream cone that has a diameter of 7 and a slant height of 17. Calculate the volume of the cone to the nearest centimeters cubed. So the first thing that we're going to do is we're going to look at what the volume of a cone shape is. Okay, volume of a cone is this formula here, V equals 1/3 pi r squared h. And then we're going to draw a picture of our ice cream cone. So that is over here, as you can see. The radius is going to be 3.5 because that's half of 7, which was the diameter. And then a slant height of 17 is referring to this height here. But when we're using this value for h in our formula, what they're actually referring to is this height here, the height of our entire shape in red. So in order to do that, we're going to have to use Pythagoras Theorem. So if we have our right angle triangle, okay, we have this length, which is 17, this length, which is 3.5. So we're going to have 17 squared, okay, because that's our hypotenuse, equals 3.5 squared plus h squared. Solve it, and we're going to get 16.63. We can then substitute our information that we now have into our volume formula. Okay, so a radius of 3.5, a height of 16.63, which we've been able to calculate. Substitute those values, 1/3 times pi times 3.5 squared times h, which is 16.63. We end up with 213 centimeters cubed. So that is the answer to part A. Looking at part B, how many milliliters of ice cream can the cone hold if the ice cream is only filled level with the top of the cone? So we're not exceeding the top, we're just filling in what can fill into the actual cone. So again, we know that 1 centimeter cubed equals 1 milliliter. So that means 213 centimeters cubed equals 213 milliliters, which means the cone can hold 213 ml of ice cream. Having a go now at the questions in exercise 10.5. If you have any questions, leave them in the comments below and I'll be happy to answer them. Have a good day. Bye.